off. And if we've got time at the end, I might take 1 or 2 questions. I'm not going to do a whole bunch. You've got 2 days to get this done. As you've been turning in homework, some of you are doing a great job getting all the homework done, asking questions on the tough problems, getting things straightened out. Some of you, not so much, you're just ignoring things and then hoping they go away. Some of you are just writing answers down on the paper. I'm really not sure where that comes from. Oh, wait, it's an odd. It's a little strange that you can write down everything else has work to it, and then you've got a couple odd problems at the end that just miraculously the answer shows up. That's a little strange. I'd be careful about that. Okay? All right. So here's what we went over yesterday. We started talking about hyperbolas, and we had this huge box here with all of this information, fairly specific about how we work with a hyperbola. And then we said, you know, we can graph this, and we've got track of the transverse axis, the conjugate axis. We talked about why it's called that and everything. We talked about why we use a squared plus b squared equals c squared, why we'd have to add those two together in order to get the distance from the center to the focus and everything. And then we went through and we looked at this. We said, you know, you can really reduce this. If you know how to graph an ellipse, it's really easy to graph a hyperbola if you just keep a couple of things in mind. Okay, they're graphed just like we graph an ellipse, except for there are 2 branches and they open outside that little rectangle that we can draw. Hyperbolas open in the direction of the positive squared variable. Okay, we use the a squared plus b squared equals c squared because we have to add the 2 of those together, not subtract, to make sure that the foci are definitely going to be outside that rectangle. And then we use the center and the the center and the diagonals in order to come up with the equation for the asymptotes. And the easiest way to write it is in point slope form with a plus or minus in front of the slope there. So we went through and we graphed a couple of these. Okay, we ended. Let's come back here and let's do this one right here. Let's do B. So the center of this one is at 0, 0. Okay, we know that because we didn't change the x or the y by adding or subtracting anything. So we're at 0, 0. We look underneath this variable. It's a 4, so we take the square root and we go in that variable's direction that far. So I'm going to go 2 units up here and 2 units down here. Underneath the x is a 9, so I'm going to go 3 units over here and 3 units over here. And then we're going to draw this rectangle. We're going to keep in mind that we said that it opens in the direction of the positive squared variable. So I'm going to go ahead and draw the rectangle, and I'm going to draw the asymptotes, because remember, those allow us to accurately graph the 2 branches. So it looks something like this, and then I'm going to come back here. In which direction does this open? Y is positive. It opens up and down. Again, don't confuse that with the parabola. Okay? When it's a parabola, it's only got 1 squared variable. Okay? If it's a y squared, it's going to open to the left or the right. Okay? If it's an x squared, it's going to open up or down. Here there are 2 squared variables. You go off which one's positive, it opens in that direction. So it opens in the y direction, so I'm going to make that nice and fat right there. We know we're going to go along the asymptote, hit this point right here, curve back up and grab that asymptote here, run along here, hit this, and go like that. Now, that's a pretty good graph. It's not complete because it's not labeled. I've got the asymptotes. I've got these 2 points right here, which we call vertices. So I'm going to label a vertex here and here. This would be 0, 2, and this would be 0, -2. Notice that those are kind of conjugates of each other if you want. The center is at 0, 0. Again, because we're going up and down, the only coordinate that changes is the y. And then I need to figure out what the foci is. Okay, where are the foci? So I take these 2. Doesn't matter which order. It's just going to be 4 plus 9 equals c squared. So that means c equals radical 13. So that means I go up radical 13, which is a little bit less than 4. So this is going to be 0, radical 13. That's one focus. And then the other focus is down here at 0 minus radical 13. So I've got those things labeled right there. I don't need to label the end points of this box right here. Is there anything else I need to come up with? The asymptotes. So remember, all you have to do is just grab whatever the y part is. So that's going to be y. equals plus or minus, and then we're going to have whatever the x part is. And then I just need to figure out what the slope is. Rise over run. Rise have to do with the y's. Run has to do with the x's. So I look underneath the y, I find a 4, take the square root, so I'm going to have a 2. And underneath the x, that's going to have to do with the run, take the square root. There we go right there. So there are the 5 points that you need to label. There's the asymptote. If they did ask anything else, there are a couple of other things that we ought to be able to keep track of. Don't say anything out loud. What is the equation of the transverse axis? Equation of the transverse axis. So you've got to know the vocabulary. What does it mean to be a transverse axis? Transverse, it's going to cut across the 2. It's going to be right here. What is it? It's x equals 0. Okay, remember all those 5 points right there, they lie on the transverse axis. And then we've got another one. It's called the what axis? Conjugate axis, and it would be y equals 0 in this case. So this is the transverse axis, and this is the conjugate axis. Again, they normally don't ask for that. They're really not part of the graph. They're just some symmetry lines that we could draw that might help us draw a more accurate thing, or at least keep the coordinates straight for each of the points that we do have to label. Okay, any questions? Easy enough? Okay. Let's come down here. We'll do both of these. It says, put the equation in graph-friendly form and label the important parts. So let's look at this one right here. Similar to when we graphed an ellipse. In fact, if you had to say, really, what's the difference between a hyperbola and an ellipse? Just the plus or minus in between there. You put a plus here, you've got an ellipse. With those being different signs, one positive, one negative, okay, it's going to be a hyperbola. What's wrong with this? It's not equal to 1. So we take care of that by dividing everything by 4. So I get y squared over 4 minus x squared over, I'm going to go ahead and write it as 1 equals 1. Center 0, 0. Let's do this. Remember I said yesterday, a lot of people think the asymptotes are the hardest thing to figure out. Could we write down what the asymptotes are right now? Y equals plus or minus, and then I'm going to have an x. Term with the y, term with the x. Just that, is it y plus or minus a k? Is it x plus or minus an h? Okay. How do I figure out what number goes on the top? Underneath the y, 2. Underneath the x, a 1. So it's just y equals plus or minus 2x. Okay, so let's go ahead and draw this. In the y direction, we're going to go up 2 and down 2. In the x direction, we're going to go over 1 and back 1. Here's our fundamental rectangle. Figure out whether it opens up or down. Which is it? Up and down. Okay, just like that last one that we did. So I'll go ahead and draw those points. Swing in here, hit that one, go up. Swing in here, hit that one, go down. Center 0, 0. Vertex at 0, 2. Vertex at 0, 2. Whoops, 0, negative 2. Where's the focus? How far is it from the center? What's C? Yeah. Add those together, you get 5 equals c squared, so c equals radical 5. So it's going to be right here at 0 radical 5. That's one focus. And then this other one's going to be here at 0 negative radical 5. That'll be the other focus. If I graphed and labeled all that stuff on a test, would that be pretty convincing that I know what I'm doing? Okay, that's good enough. We don't need to draw the conjugate axis or the transverse axis. We need to know where they are. If asked, or if they tell us where it is, we might need to use that to come up with an equation, but that's good right there. Any questions? Sure? Okay, raise your hand if you think these are easy. Excellent. Okay, let's hope when we put all three of them together and maybe even throw in a circle here or there on a quiz that you can still do that. It should still be pretty easy. By the way, did we get the asymptotes right? Y-intercept is 0. That's easy to spot. And then we rise 2 and run 1, or go down 2 and run 1. Okay. Amelia, what's wrong with this?
Oh, it's all on the same side.
Okay. All on the same side. We need some number over here. And what else?
Hasn't been like
Factored order. We haven't completed the square, right? Remember, every one of these in their graph-friendly form has a perfect square in it. So we're going to collect the x's together. So that's going to be x squared minus 4x. And then I'm going to collect the y's together. That's minus a y squared minus 4y. And then over on the other side, I can put a 9. Can I just start completing the square here? Okay. I can on this one, but not on this one right here. So really, it would be better if I did this. Now, I don't have to write the whole thing again. How can I make it so I can complete the square on this one? Factor out a negative. If I factor out a negative, that's going to turn that to a plus, and then I can complete the square. Again, this is pretty easy for the most part, but please don't lose track of a little detail like that. On an ellipse, these are going to be positive. They're going to be the same sign. On a hyperbola, because of that negative, you better make sure that you factor that out correctly. So that's going to be a negative 2. I'm going to change colors here. Negative 2. And I did notice when I was correcting one of the assignments, a lot of people did this completing the square wrong. Not a lot, but some people. Okay, so that's going to be plus 4. I'm going to take half this one. This is a positive 2. That means I square that. I put a 4 here. Now, it's inside parentheses. What did I say you should do? Draw that little line. That's a negative 4. How do I compensate on the other side? Subtract 4 there. So here's what we get. I've got a y minus 2, an x minus 2, quantity squared, minus a y plus 2 quantity squared equals 9. And divide by 9. Why is this one unique? Is this a circle? It's still not a circle. It looks like a circle. If you stopped right here, it would have looked a heck of a lot like a circle. But remember, we know for a fact, because I've got two squared variables on the same side and they have different signs, we know it's going to be a hyperbola. Okay, we could tweak one thing on this. It's not going to be a fundamental rectangle, technically speaking. What would it be?
Square.
Fundamental square. So this is centered at, please be careful on the quiz and on the test. Find the x. That's going to be 2 and negative 2. So over 2 and down 2. There's our center. We're going to go 3 units in all 4 directions. So we're going to go 3 units up here and 3 units down here, 3 units over here and 3 units over there. And I'm going to draw the fundamental. In this particular case, this doesn't happen very often, but in this particular case, we've got a fundamental square. So we're just going to draw those diagonals. Again, make sure you line up the diagonals so it for sure goes through the center of that rectangle. Trevor, which way does it open? In the x direction, right? So I'm going to make this one nice and big and that one nice and big. Run along here, like that. Run along here, hit that. Again, if you try and draw a hyperbola without drawing the square, in this case, fundamental rectangle in most cases, and the diagonals for the asymptotes, it's going to look awful. Okay, so make sure you get that rectangle and the diagonals on there. So you've got the vertices and the asymptotes to help shape that graph. I'll go ahead and label the center. The center is 2, negative 2. This vertex here is going to be, well, let's see. If I'm going left and right, then the only coordinate that's changing is the x-coordinate, right? So I'm going to go forward 3 units. That's going to put me at 5, negative 2. And this one right here, that vertex is going to put me at Well, I back up 3, so that's going to put me at -1, comma, -2. Again, notice how they all have the same y coordinate. What's the equation for the transverse axis? Y equals -2, okay? Now I've got to find the foci. I put the two of these together. That's going to be 18, and that equals c squared. So I'm looking at a number that's a little bit bigger than 4, right? So that means I go forward a little more than 4, and I go back a little more than 4. So I'd be about right there and about right there. And I can label the two of those. Now, the other day somebody said, well, how should we write these down? Okay. So again, this is why we call it the conjugate axis, right in the middle here. Go on either side, in this case, to the left and the right, you get conjugates. So we started off at 2. We're going to add radical 18. Y coordinates -2. This would be 2 minus radical 18, comma -2. And question, yeah.
So wouldn't we want to reduce the radical to
Sure.
3?
Could we rewrite that as 3 radical 2? You bet. So 2 plus 3 radical 2. If this were a test, I'd probably take off, I don't know, maybe 1/4 of a point, maybe 1/10 of a point.
Or 0 of a point.
It wouldn't affect your grade at all. Yeah. I'm more interested, do you know how to graph? Can you accurately graph and accurately label a hyperbola? So yeah, you can write it like that. Any questions? We done? No, we're not. What else do we need to write?
Transverse and
Okay. You don't have to write the conjugate or the transverse axis usually unless they ask us for it. But we do have to write asymptote. Okay, now let's look at this. Again, this should not be difficult. I would really feel bad, and I'd probably get angry if somebody misses this on a test. All you need to do to write this down is grab the stuff with the y plus 2 equals, write a plus or minus, write down the stuff with the x. That's going to be x minus 2. If you can't at least do that, you're not paying attention, you're not working hard enough, you don't really care about what goes on here. Okay? The only thing we need to do to finish this, the only thing that's even remotely difficult is figuring out what the slope is.
it's 1.
Underneath the y is where we find something to do with the rise, so that's going to be 3. And underneath the x, that's where we're going to find the run. That's going to be a 3. So in this case, it's 3 over 3, or it's just slope is 1. Okay? If you left it like that, I'd be totally fine with it. Okay? Any questions?
Okay.
Yeah.
So when we're graphing it, do we need to write 2 separate things, or can we say like asymptotes this?
No, you can just write the plus or minus. Okay? I mean, you should know that that's what it is. It goes through this point here, 2 comma -2, and look, rise 3, run 3. You should be able to find it either using this point and going up this far on the fundamental rectangle, over this far in the fundamental rectangle to get to the corner, or using this nice little technique that I showed you. It should match up either way. You should understand it both ways. Questions? Sure? Okay. So are we done with everything on those 2 pages? Okay. So on the next couple pages, it gave examples of stuff like what you're going to see on the assignment and what you could see on the quiz and on the test. Information about the hyperbola. And you've got to go backwards. Instead of having the equation and you figure out all the important parts, label them, graph it, all that sort of stuff, now we're given information and we have to figure out, my gosh, what would this have looked like? So let's take a good look at this one right here. Now, yesterday when we left off, I said, yeah, let's just go ahead and try B. I think you can do that. I'll show you why B is a little bit on the tricky side. They give us the foci, 0 plus or minus 2. So I've got a focus right here and a focus right here. Just drawing that much, you automatically know what it should look like.
Y should go first.
Y should be positive, right? And what's the center? So we could write, again, if this were a test question, you ought to be able to write y squared minus x squared equals 1. All we have to do now is figure out what's underneath there.
They're the same on the bottom.
They are the same. Why are they the same?
Because if there's an asymptote at -x,
Okay, if one of them looks like this, if the asymptote looks like that, if the slope is -1 or +1, that means the rise was the same as the run. That means the A was the same as the B. So I'm going to put an a squared here and an a squared there. Does anybody know how we'd find it?
Use a squared plus a squared equals.
Very good. A squared plus a squared equals 4. Because this distance right here is c, it's 2. So that's going to be a 4. So I've got 2a squared equals 4. That means a squared equals 2. Do I need to go through and figure out, hey, you know what a is? A's got to be radical 2. Does that matter? Doesn't matter if all it said was find the equation. Now, if it said graph it and everything else, we'd want to know what those are. So this is going to be a 2 here and a 2 here. That's the equation. Any questions? If it said graph it, label it, all that sort of stuff, we'd have more work to do, but all it says here is just come up with the equation. Any questions? Sure? Okay. Let's slide down here and take a look at this one then. It says graph and label the important parts. So let's take a look at this. What is this?
It's a hyperbola.
It still is a hyperbola. It's already in the graph-friendly form, isn't it? Yeah. Center is at -2, 1, back 2, and up 1.
You go one in each direction.
So we have a fundamental square.
Cute.
Draw the asymptotes. While you're drawing the asymptotes, because that's a pretty mindless thing to do, you're thinking about the next thing I need to know is I need to know which direction the branch is open.
X-ray.
So we'll put a point right here and a point right here. Run along the asymptote, hit that vertex, curve around and right along the asymptote again. Hit that, curve around like this. Center is -2, 1. That vertex is at -1, 1. And that vertex is at -3, 1. And you come up with the foci and the equation for the asymptotes. You come up with the locations, coordinates of the foci, and the equation of the asymptotes.
Sweet.
Parker, how do I find the foci?
Foci, you add the two together.
Add the two of them together, so that's going to be 2 equals c squared.
Take the square root of that.
Take the square root of that. So I'm going to go to the square root in each direction from the center. So square root of 2 is about 1.4. So we're going to go to about right there. There's a focus, and we're going to go to about right there. There's a focus. And then I want to label those 2 points. Which coordinate changes from the center if I'm going left and right?
That one.
X does, right? By how much? Square root of 2. So this is going to be -2 plus radical 2 comma 1. And this is going to be -2 minus radical 2 comma 1. I've got all those labeled. And then Clayton, can you tell me what the equation is for the asymptotes?
Y minus 1 equals 1 times x plus 2.
And we can put a plus or minus on there and we've got both of them, right? Okay, very good. Any questions? Is this one hard?
No.
Nope. Okay. So we go through and we divide everything by 4, which means I've got this, y minus 3 over 4, x minus 1 squared over 1 equals 1. And from there, finding the center, the vertices, the asymptotes, all of that stuff shouldn't be too terribly bad. Okay, everybody's eyes up here, please. Take a good look. If you have it right here, if that's going to be the center, the whole thing's going to be wrong, isn't it? Okay? Please don't forget, you have to find the x term, the stuff with the x. So we're going to be at 1, 3, not 3, 1. Please don't get in the habit. I've warned you about it about a million times, so please make sure you don't do that. So we're going to be here. Opens. Up and down. It's only the y coordinate that changes. In fact, I could write the foci right next to these, and I can already fill in one of the coordinates. It's got to be 1. How far do I go? Yeah, radical 5. Okay, so a little bit more than 2. So this is going to be that old y coordinate 3 plus radical 5, and that old y coordinate 3 minus radical 5. Stuff with the y. Marissa, tell me what the asymptotes are.
Y minus 3 equals plus or minus 2 parentheses x minus minus parentheses.
Oops. Because it would be underneath the y is a 4, so square root, that's going to be a 2. And underneath the x, square root of that's going to be a 1, so I've got a 2 over 1. Remember, it's not this number, it's not 4 and 1, it's the square root of 4 and the square root of 1. Okay? Any questions? Okay. So if you've looked at the homework, I've picked a couple of problems here. There are four problems that I want to take a quick look at. Again, you really have to work hard at getting through all the homework understanding, especially the story problem type ones and the applications of these.
Wait.
If you understand fundamentally how these work, it doesn't matter whether they give you the equation and say graph it, or give you the graph and say come up with the equation. Or say, hey, here's a story problem where I can fit a hyperbola, a parabola, an ellipse, or something like that. Where's the easiest place to put your center if you've got a story problem where you can move around where the center is? 0, 0 is the easiest place to put it. Okay? So, sure. Okay, so let's take a look at this one. It says, find the equation of the hyperbola given the following information. Again, you don't have to graph it, just come up with the equation. That's all I want to do for now. So the center is -3, -4. That tells us a huge amount right there. Let's roughly sketch where that would be. -3 and -4. Guys, take a look here. Focus at -3, -8, way down here, and a vertex at -3, -2. So there's a vertex here, here's the center, and there's a focus. There's got to be a vertex right there, right? Blow this up just a little bit. If that's all we could do is label that information on a little sketch, we ought to be able to come up with most of the equation. Because this is h and k right here. My question for you is, which one's going to be positive and which one's going to be negative? Y is going to be positive. So this is going to be y plus 4 quantity squared. x plus 3 quantity squared equals 1. Again, we're nearly there. All you need to do is find, hey, what's the number underneath the y and what's the number underneath the x? So let's take a good look at this. Maybe I'll draw this a little bit bigger so we can actually use it. So if that's the center and it's got a focus down here at, that's -4 and that's -8, okay? And there's a focus. How far is it from here to here? It's 4, okay? And that would be C, right? So C's got to be 4. And then it says we've got a vertex at -3, -2. If this is -2, how far is it from here to here? 2. And that's got to be under, okay, under the y. Okay, we take that and square it. So A is going to be 2. So this is going to be a 4. We've got that figured out. And then how are A and C related? A squared plus B squared equals C squared if you wanted to move that around and solve for what B was. Okay, so in this case, I'm going to take, let's see, we've got 4 plus B squared equals C squared. So that would be 16. So what's B squared? B squared is going to be 12. Okay. Trouble there?
Yeah.
Got it figured out?
Yeah.
Sounds convincing. Good? Okay, let's take a look at number 45.
I didn't square.
Would you go ahead and do 45?
This is so easy. So are these numbers 41 and 45 in the book that you sent me?
Yep, they are.
Are you sure?
If not, they're really close to it.
Okay. That's not the same thing. It is not.
This is from a different edition, so it might be slightly different. You want to check and match them up. They may have thrown some extra thought questions at the beginning or something.
Good job, Zach.
If you're having trouble, this can be a confusing piece of information, this asymptote right here. So we won't worry about that one too much, but at least graph the two of these. And if you've got a vertex here and a vertex there, I mean, that's a huge giveaway right there. If you've been paying attention to how we construct the asymptotes, that should be a huge giveaway. But again, people generally struggle with the asymptotes a little bit more than the others. I see some pencils dropping. Some people are done. I see one person in particular texting.
I wonder who that would be.
Somebody whose grade's going to suffer.
I'm done.
Somebody whose parents might get a phone call. Somebody who might have to stick around after for a chat. Okay, if nothing else, just the fact that the vertices are like this, which variable is going to be positive? X is going to be positive, right? Okay, now, if you go through and say, you know what, I know this is at -1 and this is at 3, that means that's got to be right in the middle there, and you find the center that way, that's great. Or, let's use what we did before, but let's do it backwards. That's the stuff with the X, right? That's the stuff with the Y. We said X is going to be positive, so it's going to go first. So it's going to be X minus 1 quantity squared minus Y plus 1 quantity squared. Each of those is going to go over a number, and it's going to equal 1. Now, if this point right here is 1 comma negative 1, wouldn't you end up at the same place? But isn't using this idea backwards, isn't that a little bit easier? Okay, now, how far is it from the center to a vertex? From here to here, 2 units. That's in the x direction, so that's how far I go. What do I put underneath the x? I put 4, because I square that. So I'm going to put a 4 right here. And then if you're really clever, there are a couple other things that we could do. Or we could just look at this and think, you know what? I know how to make an asymptote from the equation. Could I take the asymptote and go backwards and write down something about the equation? Now, you do have to be just a little bit careful about this. The square root of this is what would go underneath that. That's a 2. So that means what goes underneath this would have to be the square of that. That's got to be a 9. Now, does that actually work every single time? Can you just take these and put them over here? You have to be a little bit careful about that, because what if this had turned out to be 6 over 4? You could have reduced it. Okay, so you do have to be a little bit careful about that, but some way or another, I don't think they give you any like that, but some way or another, that 3 and that 2 is going to have something to do with what goes under that, the x and the y, yeah.
So if we got the slope of like 6 over 4, would we then reduce it and then square it and put underneath? Or would you?
Yeah, so normally this, I would never give you something like this on a test where you had to go backwards. There'd need to be some other information. The other thing that we could do is, well, let's see, they didn't tell us where any of those were. Yeah, so what you'd have to do on this one, it would actually work out. So if we actually drew in one of these, so this would be up 3 and over 2. If you drew in one of those asymptotes, if you drew this like this, okay, that would be like the corner of the rectangle. The only thing that you'd find is these vertices couldn't be here unless it was exactly 3 over 2 and it didn't come from reducing. Like what if the vertex was over here and that was 4? Then in order to follow this up to get to the corner, this would have to be 6. So that would help you figure it out that way. Okay. So the bottom line is hyperbolas are the most complicated one, but they're nowhere near as complicated as people think they are, especially if you just understand these basics. There are some tricky things that could crop up. Okay, but they're not going to give you something like that on the homework for the most part, and I'm certainly not going to give you something like that on the test. Okay, any questions? Okay, just look at, let's see, what one did I want to do? 15. Look at 15. So I'll make that a little bit larger. It's just a matching thing. Which ones could we cross off immediately? And there are little minus signs here if you can't see them. You can cross off what? Y. Okay. The y is the positive one. It would have to open up or down. In this case, we've got it opening left to right, so it's got to be one of the 2 of those. Has to be... It's got to be this one right here. Okay. Has to be that one right there, because from the center, how far do we go to get to that? 1 unit, so there's got to be 1 squared underneath there. So that's it. If we were to draw the fundamental rectangle would look like this. Okay. It would look the same on this one. Whoops, other one here. Okay. If it were like this, it would be wider the other way. Okay. And then here's the last one. Find the center, transverse axis, vertices, foci, and asymptotes, and graph the equation. Okay. Now, is that hard? That should be easy, shouldn't it? Okay. Given everything that we've gone over, that should be a breeze. Okay. That's what your homework is like. I think we've done one nearly like every single one of them. The only difference would be there are a couple story problems, 2 or 3 of them, where they've got some sort of hyperbolic shape. Your choice there, the easiest thing to do to make the problem a little bit easier is, where should you put the center?
0, 0.
Put the center of the hyperbola at 0, 0. Okay, any questions? Sure?